Yes, so the Internet of Things is a concept that was coined, Sergey, in 1998. It basically started with RFID and RFID tags. And then later, we started to talk about the things in general, the sensors, M2M, machine to machine, and more industrial type of applications. We estimate that today, the representation of all these things connected is a revenue stream of $2.4 trillion. The biggest component in that at this moment is machine to machine. And so we see machine to machine as a component in the Internet of Things. And we estimate that machine to machine is around 100 billion revenue stream on a yearly basis. And in that, the biggest segment and component is predictive maintenance, where we go from engines to software-defined engines, and where you get a lot of information and data, and it can give you analytics on when machines need maintenance and need intervention.
Okay, thank you. And what about transition from M2M to already exist Internet of Things and future Internet of Everything? How this impact on all levels of telecom networks? I mean, networks, capacity, standards, maybe applications.
So the whole transition that we see happening is that the Internet of Things is a technology. And to get all the things connected, you need gateways, you need protocol converters. There's still so many different protocols in different segments. If you just take smart grid, we estimate that we still have on a global basis more than 260 protocols. If you take the segment of healthcare, different things. If you take home automation. And so there will be a lot of conversion time, and probably never we will end up on one protocol. And so it's first that whole development of how do you connect the things, which segments of the market are most easy to start with. That's what we see as basically the infrastructural element. And then we will get a software level on top of that, and where we get the things connected. And that's where we will have gateways and interpretation. And then on top of that, you will get another layer of software, and that will be the link to applications. We have basically developed what we call 7-layer framing model for the industry to at least start to have the same taxonomy and that we get the same words out. It's a relatively young industry where a lot of development from a taxonomy point of view, a protocol point of view, and then standardization still has to happen.
So what about standards, like how the industry could cope with that?
So it's like the whole internet started 30 years ago, and when we started the internet and we started connectivity, you had AppleNet and you had DECnet, and over time we got basically standardization from 86 protocols to around 7 or 8 today. But it has been a process of 10, 15, 20 years. And so now we're starting to look at the industrial side of the house, healthcare, manufacturing, oil and gas, mining, smart grids. There is a long way to go before these segments will all have global standards. Probably we will never have total global open standards. If you think about electricity, how many plugs do we have on the world? At least 10, 15 different ones. I travel with a suitcase full of plugs. And then you have 110 volts and 220 volts and 50 hertz and 60 hertz. And so imagine if you now go one layer deeper in that, in the things, all these different installed bases that we have. And before we can convert that to one standard, I think probably we will end up in every segment with 3 standards, 5 standards, 10 standards. And one example on top of that, if you think about the connected cars, we haven't even decided in the world on which side of the road cars will drive. And that you have part of the world with the steering wheel on the left side, on the right side. And so one standard would an utopia. And that we have to be pragmatic and see what the right number of standards are.
Okay. So, what about future architecture of Internet of Everything? Would it be centralized or atomized, like fork network you taught us today? And what about central position of current carriers? Would it be safe, or they just would moved? So, what about future of carriers in the world of Internet of Everything?
Yeah. So if I break down the question, so first, the Internet of Everything in the different segments will be a different type of models. What I mean by that is, so healthcare will have its Internet of Everything, manufacturing will have its Internet of Everything, and then as a jigsaw, we will try to have all these Internet of Everythings communicating to each other. But it will not be one horizontal type of overlay for all segments. And then you get the question, how do you run these Internet of Things, these Internet of Everythings? In some cases it will be the traditional service providers, and that's who are mostly in the business of connectivity, but also more and more services. But if you take cities, the big question for who operates it is first, who owns the data? Because the rights of the data, do the municipalities own that? Do the citizens own that? And so you see cities who will have their own operator. You also see business models where we have what we call special purpose vehicles. And so where a service provider will be created to deliver the services to their customers. And so we think that probably we will end up between 7 and 10 type of different business models, where you will have different type of operators. And that one last example, that if you talk about city Wi-Fi, that we think that city Wi-Fi is going to be essential as a blanket over the city. Can be the service provider. Again, some cities have their own operator. It can be a fund that basically gets concession for a couple of years from the municipality, and that they will make the investment and can collect the revenue. So a lot of different models is basically my answer.
Okay, thank you. So please tell us about key segments of Internet of Things today, the main perspective segments and maybe trends on this field.
So if you look at the Internet of Things in the different segments, in the different verticals, we think that some will go faster than others. And criteria that we use is first, what is the opportunity? How big is the market? And we have classified that smart cities, public services is a big pie. Manufacturing, and then specifically in manufacturing, the discrete side of manufacturing, oil and gas, mining, and that are big markets. And so companies always go first after the big markets. But then we have the question, how difficult is that segment? Is it regulated? Is it unregulated? Is there a willingness to change? Because it will require new business models. And so we have put all kinds of filters on how big is the market, how regulated is the market, how ready is the market, how ready is the industry. And these criteria have led us to the conclusion that at this moment we qualify public services, cities specifically, and then manufacturing, discrete manufacturing, oil and gas, mining and transport as the biggest opportunities.
Okay, so you mentioned smart cities, and I know that you are part of many international commission on urban studies.
Mm-hmm.
So, and how the concept of Internet of Things and smart cities could help to resolve a problem of modern cities, and how Cisco could help in this question.
So if you talk about the problems of modern cities, there are some what we call different type of clusters. And that's in a lot of developing countries where we still have people who have no access to healthcare, no education or access to education. And so then specifically that in countries like India, in Brazil, and you have different priorities. And then if you go to the developed world, where probably mostly traffic congestion and that lack of access to services are the issues. So if you break it down, and that's from a technology point of view, to address the problems, we look at what we call the most challenging issues that a city has. Is it loss of water? Is it congestion? Is it poverty? Is it violence? And so that prioritizes which services we go after first. Then secondly, it's also the governance model. That most cities still look very, what we call in segments. And so they look at water, they look at electricity, and they look at gas, and they have a road transportation organization. And where you have cities who look more from a digital overlay point of view, and what could technology, what could the Internet of Things mean? So the better a city is organized from a governance point of view, and you see more and more cities who now have a vice mayor who will look at all the infrastructure investments and say, hey, if I spend a little bit less in water, a little bit less here, then I can create, for instance, a city Wi-Fi environment by which I can come up with citizen services. And so it's the governance model, and it is the priorities of the problems that cities have. And that's where we think you will see fast progress, or slow progress, or sometimes even no progress.
Okay, so could you give us some examples besides Barcelona, because we know this example well? Thank you.
Barcelona, but you know that. But then also in Korea, we have the city of Incheon, which has been a role model. Toronto, Toronto waterfront. Next to that, we have cities like Rio de Janeiro, where the Olympics will be held. We just had soccer. We have cities in Amsterdam, as an example, where a lot of things are being done from a utilization point of view of buildings, of reducing CO2. Copenhagen is a fantastic case study. Then we have Hamburg, that is driven by the harbor and efficiency of getting more trucks over narrow roads. So that we have an engagement with more than 80 cities around the world. 80, more than 80. And that where we really have a smart city type of plan. In total, that we have hundreds of projects in relation to cities. And then what we really call the lighthouse cities, then I come back to the ones like Barcelona, like Songdo, like Copenhagen, like Amsterdam, where we make the showcases and the videos to show the world what is possible.
So I think my last question would be about Moscow problem. So are there a difference between Moscow problem and problem with of other main modern cities? So is there a difference or just are they common?
There are, but like I said, there are perhaps 6 or 7 type of clusters of problems. And that's so physical safety and security. And that there are cities who rate that is the biggest issue. Not all cities rate that as the biggest. And some cities say it's congestion, and other cities, specifically in the third world, it's access to healthcare, education, can be waste management. And so we see groups of cities with the same type of problems, and we try to also look at the world and in groups of cities who have bigger similarities and can learn from each other.
So maybe about role of Cisco in this process. I mean, smart city, Moscow is smart city. So do you take part on this process, some plans?
Definitely. Yeah, that's Moscow. We are very engaged in physical safety and security, in transport. I think Moscow is doing great in relation to traffic and to gather data in more than 6,000 of these integrated operations centers that come up with intelligence out of that that's being fed to applications on the cell phone. And my understanding is that probably in Moscow the most used application is traffic information.
Yes.